So let's look at negative exponents. If I have a to the negative m, or just a negative exponent, what that does is to create a positive exponent, which we typically want, we take the reciprocal of it and move it underneath the fraction. So that's where we're going to start in our more rules of exponents. So if we had 2 to the negative 1, using the same idea, that becomes 1 over 2, or 1/2. 5 to the negative 2 becomes 1 over 5 squared, which we square 5 and it's 1 over 25. And here I have 3x to the negative 2 and 3x to the negative 2. And parentheses play an important role here. The parentheses with the negative 2 says the whole thing goes underneath. Become a positive 2 down there. Then we square it, and that is 9x squared. What's different in this one, because the negative 2 only applies to the x, is the x is what goes down there and becomes squared. Very different answers here. 1 over 9x squared as opposed to 3 over x squared. Now what if we wanted to bring in what we call raising a quotient to a power? In this case, we have a fraction to some exponent. So we have here 3/5 to the third. And in the example, they make it 3 to the third and 5 to the third, which then would eventually become 27 and 125. So we're taking that exponent and applying it to both the numerator and the denominator. So let's look at our next one. If I had 4x over x to the third squared, it's going to become 4 squared over x to the third squared, which the top is then 16, and the bottom, like we talked about in the previous section, it's going to be 3 times 2, or x to the 6th. If I had 5x, that quantity squared, over 10, and it's going to be 25x squared over 10, which we can look and simplify a little bit further. 25 over 10, we can divide both by 5, and it becomes 5x squared over 2. Now, we keep that idea going, and what if we had to divide powers with the same base? So in the previous section, we said, well, if we multiply something like am times an, you would add the two exponents. So now, well, what if one of these was negative? So what if it was am times a to the negative n? Well, using that idea of addition, it would now be am minus n, because it's plus a negative. Well, we just said a minute ago that when it's a negative, it's in a fraction. So what this also could be is a to the m over a to the n. And that's what our rule is talking about here. Whenever it's in division, you subtract the exponents. So let's look here. If I had j to the second, k to the sixth, j to the fifth, k, and k, that's saying I can do j to the second minus 5, it's 2 minus 5, and k to the 6 minus, that's a 1, to give me an answer of j to the negative third and k to the fifth. Now, we have to make sure both exponents are positive, so then the j would go down, and it's k to the fifth over j to the third is our final answer. I want to show you maybe a little different way we could solve it. So what if we first started with, what if we took that same problem and said, well, which part has more? Because really, if I say j to the second over j to the fifth and expand them out, I have 2 on top, 5 on bottom. Those are going to reduce. I'm going to be left with 3. So this one has 3 more. So it's going to have 3 j's on the bottom when I reduce everything out. K to the 6 over k. Well, if I had 6 k's up here, and 1 on the bottom, I cross these out, I'm left with 5 on top, so now it's k to the fifth as my answer, which, as we just found, was the same answer as before. So you can use this subtraction idea or this reducing idea to help you as well. Where we get in trouble is when you have to look at coefficients, because 6 over 3 still reduces to be 2, so 2 on top. Now, a to the negative 3, a to the fifth. I'm going to write a to the negative 3 minus 5, and then b to the 7 over 2, we could write it as b to the 7 minus 2. This comes out to be 2a to the negative 8, b to the fifth, which is then 2b to the 5th over a to the 8th. And that's using our subtraction rule. Maybe you want to take a different approach. Let's go back up here. We still know it's 2. Now if I have a to the third and a to the negative third and a to the 5th, I'm going to move this down and make it positive. So if I move that down, I now have 8 a's on the bottom. B to the 7th over b squared, I have 5 more on top. So when I reduce, I'm left with b to the 5th. And so my answer turns out to be the same thing, 2b to the 5th over a to the 8th. It really depends on which approach you want to take. So next, we're going to simplify here. So I have 12 over 4 becomes 3. A to the negative 1 over 5, I'm going to take the negative 1, move it down, and that now says I have 6 a's on the bottom. B to the 6th over b to the negative 1, I'm going to move this one up, which now gives me b to the 7th. And then c to the negative 3 c over c to the 5th. Move the negative 3 down, it's now c to the 8th. My final answer is 3, b to the 7th, a to the 6th, c to the 8th. Everything positive, reduced, and we're good to go. Now where the last step we have to take is, well, what if we have a negative exponent on all of it? And what we're going to do is if we had something like a over b to the negative 2, I'm going to first take the reciprocal of it and make it b over a to the positive 2. So that is then going to allow us to finish the problem b squared over a squared and get to our answer. But anytime I have a negative exponent, you switch the fraction, get the reciprocal, and finish solving. So now, in this problem, I'm going to write it as 5b over a, now to a positive 2. By squaring, I get 25b squared over a squared. Next problem, we're going to take the reciprocal. So 3y to the 3rd goes up, 2x to the 4th goes down. It's still negative, but now it's a positive squared. I'm going to distribute in, that's negative 3 squared, y to the 3rd times 2, 2 squared, and x to the 4 times 2. Negative 3 squared, or negative 3 times negative 3 is positive 9. We get y to the 6th, this is 4x to the 8th. Next problem, before I flip them, I'm going to simplify inside this, because if I can get rid of terms and make it nicer, that's going to help me out. So we'll still keep the negative 2 there, but what if I simplified here? Because like negative, or 3 over negative 6 is 1 over negative 2. X to the 5th over x to the 6th is actually leaving me with an x on bottom. Y over y to the 3rd is going to leave me with a y squared on bottom. So now, instead of all of this having to flip, I'm just flipping this, which by taking the reciprocal comes out to be negative 2x y squared squared. So now it's negative 2 squared, x squared, and y to the 2 times 2, which gives me 4x squared y to the 4th. Our last problem, we're going to have to do the exponent first before we can simplify between these two. We have 4xy to the negative 2z. And then on the bottom, negative 2 squared is 4. We have an x, negative 2 is x to the negative 4, y squared, and then z to the negative 2. So the 4's are going to reduce to be gone. I have x and x to the negative 4, so I'm going to move this up to now have x to the 5th. I have y to the negative 2 and y, which moving down the negative 2 becomes y to the 4th on the bottom, and z to the negative 2. Negative 2 comes up. It's now z to the 3rd. So our answer is x to the 5th, z to the 3rd, y to the 4th.